Since the last time I tried to stream, let me do that again. Today we are doing yet another new type of interview for me, which is the low-level design. Okay, so I need to change my layout and I can go and open this. Oh, I probably didn't think it through right. Where do I write it? Oh, but yeah, here we have start practice, so I think it should be available. So again, this is Hello Interview, as you can see. Highly recommend their site. My level is senior. I will be writing in Python. Okay. We will be designing Connect 4 game. Player to take turns dropping disks into 7-column 6-row board. 7-column 6-row. Okay, the first to align 4 of their own disks vertically, horizontally, or diagonally wins. Cool. So we will work through this framework. I already know about this, but let me just spell it for you. So we will start with requirements. Basically, we will discuss what this problem is about, what are all the states and behavior that we need to track. Then we will go into entities, which are like the nouns of the system. Then we will design our classes, like what are the exact things, methods, and state that each of the class needs to support, how they will relate to each other. Then we will implement things, probably just the most important ones, and then maybe we'll be discussing, maybe the system will ask us how would we extend our design. Okay, so start by clarifying the questions and then list the final set of requirements. Okay, let's see. So we can ask clarifying questions and we can have a set of requirements, and then we can get feedback in the editor to the right. Okay, so let me copy this. Requirements Connect 4. Just to be clear, I'm solving this for the first time in my life. I have never done this before, so we'll see. Okay, and I also want to change how we are writing all this, because that's just too cumbersome to track all this. Okay, so we are connecting 4. Here we also 2 players, alternate. Okay, can I assume that it will be also x and 0 to represent the disks? Okay. On a 6, okay, 6 rows, 7 columns read. Disks can only be placed on the lowest possible place in the column. So that's one thing. Okay. Then a player wins by aligning 4 the pieces diagonally, horizontally, or vertically Sorry. Okay, so what else? Some corner conditions. So if the whole grid is filled without a winner, game ends in a draw. So that basically means that 1.A players can only choose columns. Okay, now player wins the whole grid. Yeah, just to be clear, out of scope will be the same thing that as for tic-tac-toe, so all of those things are out of scope. What else do we need to figure out? Can I keep the display out of scope, or if not, what do I need to show for each step? So no drawing the grid. Okay. Yeah, validating 1B. If a move is invalid, it should be rejected, obviously. So invalid move is adding disk to a column, to a full column, not in the right order, non-existent column, or finally if the game has ended. Those are some of the invalid moves that you can think about. Okay. Can I assume that we are always instantiating a new game if we want to play, and we don't need reset functionality? Can players decide to finish the game before finding a winner? What else should I ask here? Should players have names or any other information? No reset functionality. Reset. The game only ends by a win or draw. Players can have a full name like. Okay, but no other information. So for player has a name and the disk value. Okay. So more than 2 players also kind of breaks this game, so I will be assuming that there are just 2 players. Okay, let's see. Let's get our feedback. Great answer. Keep on. Okay. Now let's see entities and relationships. Let me copy this part. Actually, yeah, I think it will be kind of the same thing here. So it will be game, it will be board, or let's call it grid. Player. Yeah, maybe board is better. Let's keep it to board. Okay, so this is all right. Let's now remove the necessary part here below. Why am I not able to remove it? Oh, it asks me to modify this below or something. So I cannot remove this. I also cannot remove this. Yep. Okay, fine. And then I will just do it like this. Game board player. Disk color to represent 2 different piece types. Yeah, I thought actually about this, probably should have mentioned it explicitly, but I decided against that and just have whatever the player wants. But maybe, yeah, maybe we should have a disk in let's add it here so it will be in the numerator. Next question. What are the relationships between our entities? Okay, so relationships. Let's actually add this here. So game. So what does it do? Game owns board. Game owns 2 players. Players have name and disk. Okay, so the logic is basically that game will be passed the board, like the board class will be initialized, passed to the game, so game has the board class, and game has 2 players. It also keeps those as state, and then players will have, like, apart from the name, they will also have the disk, specific value of the disk. Okay, let's see. Good answers. So what am I missing? Is the one driving the flow. Yeah, that's a no-brainer. Now define the interface of the classes. For each class, specify state, properties, fields, and behavior. Spend 10 minutes, apply solid principles, blah, blah, blah. Okay, define your classes with their attributes. Let's do class design. So we have game class game, actually, let's start with things step by step. So there will be class disk of enumerator, so, and it will have, let's say, x and O equals O. So for example, this can be disk. Then there will be class player, and it will have name, which will be a string, and it will have disk, which will be disk. Then, okay, so basically those are just the states. Now the board will be a bit more interesting. So class board. So first of all, what is the state? So the state will be grid, which will be a list of what exactly will it be? It will be strings. So it will be this. So, yeah, anything else? I don't think so, right? Okay, so then what? Let's get to behaviors a bit later. So now the class game will also have, okay, it will have board, it will have player 1, player 2, it will have current player, status, which will be another enum, or status maybe is active, which will be a boolean. Oh yeah, I forgot the board will be board, player 1 will be player, and the same thing here. Current player will also be player. Is active is boolean, is ongoing about the game, and winner will be optional player, right? So it can be none while the game is ongoing. Anything else? Doesn't look like it. So now let's see what are the methods that we need to have for the board. So first of all is valid move, and column, which will be an integer, and player, which will be a player. So this is one method that we want to create. Another method, make move, and then okay, is valid move. Here we return boolean, here we return none, and then we also want to do check winner, which doesn't take any input, but it returns optional player. So if it returns none, we don't have a winner, otherwise we return the player who has won. Oh, actually, yeah, that's the problem. Probably optional disk. So we will not be storing players. We will just be storing disks. Let's also then do disk. So, oops, I don't want the board to know about the players and anything. So it just tracks disks. Okay, so and it only returns the disk of the player who has one. What else? Let me check anything else from here. So players can only choose columns. If a move is invalid, adding disk to full in the right order. Non-existing column. Player win paneling. Okay, hold grid is filled. Oh yeah, maybe this. So plus is full. Returns boolean. If the hole without winner game ends in a draw. Okay, now let's decide what are the methods here. So we don't need to display anything. How do we take the input actually? So let's just abstract this away as get input from the player. Okay. Run game. It returns none. Get input. It returns integer. So we basically ask a specific player. Maybe we pass the player here, right? Player which is player, and we ask for input and we get the column that this player wants to place. Okay. Okay, so get input. What else? Well, autoscope, but board and current player. So something like this, probably we will need to display this. Fine. I hope it works this way. So let's see. Get feedback. Reviewing your code. Analyzing your answer. Oh yeah, public make move. Okay. Okay, so we are instead doing this externally. I see. How do I remove it? Close jitter. Yeah. Actually, we do distinguish. We can only get to the draw if we already are like filled the whole board. That's my assumption. So here, let's change this then. Let's instead assume that we do plus make move, and we have player, and we have move, which is an integer, and we return boolean, which is basically true or false. So instead of us requesting the move and assuming that we always get the correct move, we start the game. Okay, then basically start. Do we even need to start? No, we just make moves. So we just assume, and we will assume that the player one is always the first one. So we don't need the start, we just do make move. Okay, really? Nice. Next question. Yes, yes. How would I detect 4 in a row in all 4 directions efficiently after the disk is placed? I actually don't want to do anything efficiently here. I will do n times m algorithm, and I will just start at each of the possible places for horizontals, diagonals, and verticals, and try to find whether there are like already 4 in a row there. Write your implementation in the editor, talk through your solution with voice or text, focus on correctness and handling edge cases. Okay, let's implement now. So let's have game class board, and at initialization we will have self read, which will be empty, and for row in range. Okay, actually we need to start with the columns, so that for column range we have 7 columns. Let's do something simpler. None times 7 columns, and we do it for in range 6. So we can theoretically also have those not as like the magic numbers, but as variables that we are passing here, but for now I'm ignoring this. Okay, so now we do this. Now how do we do def check winner self? Here we also need self. So check winner self, let's see, yep, and we are returning optional disk. Let's just, okay, we already have disk in HAM, so let's not copy paste it here. So how do I do it efficiently? I will just check horizontals, then check verticals, Actually, yep, check diagonals. So what I need to do is I actually need to define a class check winner direction, and it will be like starting row column TRDC. So row column will be integer, 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 integer. What I want to do is I want to start at a specific point and then move 4 places, 4 pieces in a specific direction. And if all of those are the same thing, then I return as that we have a winner. So how do I do that? If self read at row column is none, return, basically return. So here we are returning optional disk. So if we are returning none, it means that we haven't found the winner. Else, like disk will be okay for in range 3. So row plus equals dr, call plus equals gc. So how do I do that? I have a few options. Like either I try to control where I start, or I just don't care where I start, and I do exhaustive search, even starting with those cells where it's impossible to get the result, because it's, for example, like lower right corner. We cannot possibly move from lower right corner to the right or to the bottom even further, but it will be easier to check this way. So if row is bigger or equal to 7, yeah, so maybe let's create those calls equals 7, rows equals 6, and in a row disks in a row equals 4. So here will be calls and rows and disks in a row -1. If row is bigger or equal to, to rows, or call bigger or equal to calls, return, we basically cannot find it. Then if self read row column is not equal to disk, we return, else we continue. So if we continued through all of these steps and we have found some matching, then we just return the disk. Okay, so that's it for this submethod implementation. And then basically we do for start row in range rows for start call in range calls. So how do we do all those checks? Simple. So how do we check horizontals? If self check winner direction start row, start column, and then we want to check horizontals, so we start at this point and move to the right. So we do delta row equals 0 and delta column equals 1. Okay, let me change this because we will be reusing that. Tel equals this if horizontal is not none, return horizontal. Now we are checking verticals, which will be pretty similar. Okay, I don't like copying this code, so let me do it differently. So for gr DC symbol directions equal, so we can either move 0, 1. Oh, we need to do, yes, we need to do this. Okay, yes, or we do delta row is 1, delta column 0, or it's 1, 1. So in possible directions, attempt will be gr_dc. If attempt is not none, return attempt result. So yeah, that's it. And otherwise, return. We can not explicitly do that, but it's kind of nicer this way. So I will be returning this. Okay, this looks reasonable to me. Spend 5 minutes, get feedback. Oh yeah, down left diagonal. That was stupid, but it's very easily extensible. So we change delta row by 1, but delta column by -1. And missing self is the first parameter. That's true. Yep. Or call smaller than 0. Okay, yeah, try again, get feedback. Note to self, check results, offer letter incoming. Okay, good. Next question, implement make move column disk on board. Okay, so let's do make move. So class bin make move. So here let's also do def init self word equals word. Self equals okay, so there is some stuff. I don't want to define all this. Let's just assume that we have all of those things here. The most important thing is like the current player. Oh, I didn't actually. No, I have make move. So on board. I'm implementing it on board. Sorry, that simplifies things. So def make move, which is all this. Okay. So I actually assumed that by default we will be doing like first we'll be checking if the move is valid, and then we will be making move in the game. So is this a bad design? Should this be a private method? Yeah, maybe it should be a private method, and we will be doing like make move if self is valid move. Column disk. Yeah, the problem is that we also need some logic on the game side. So for example, here we don't even know whether the player is right or wrong, right? So we will need to do that on the caller side. But okay, here raise value ever wrong move. Oh, there is a message. Let me actually see. Hello, there has been a while. Yeah, it's been a while. I wasn't preparing for new kinds of interviews. I was doing some interviews, so yeah, I was pretty busy interviewing, and I didn't need to prepare because I had interviews to prepare myself. Like every interview is kind of a mock interview if you fail it, right? But okay, so we do this if not self is valid move. We do that, then else. So what do? We start iterating. Okay, so we have a column. So the column is x, and then we have row, which will be rows -1, while row is bigger or equal to 0 if self read self grid, so we start by row and then column is none. Then self this is equal to disk, and that's it essentially. Otherwise we do row minus equal 1, and assuming that this move is valid, so we already checked whether this column is already full. We can do it by checking the row at index 0 for this column, and then if it's not full, we definitely can put something there, and we assume that otherwise this is a valid move, and we are always returning none, so that's it. Oh yeah, this is correct. Oops. I should be more careful. Again, missing self. This is my favorite mistake. Returning the row where the disk landed. That would let the caller win checking. Yeah, actually, this is a good idea. But the problem is, yeah, it's preliminary optimization. Doing 6 by 7 times 4 is no-brainer. And we will need to complicate the code because it is not necessarily the top left corner of our structure, so it can be anywhere inside our 4 connected pieces. So yeah. How would you implement the core turn taking logic in game? Walk through what happens. Okay. Class game. So we are ignoring what happens when how would I implement this? You don't need to code anything, but I need to implement the game. Okay. What happens? How did we define it? We had make move, right? So, and make move was player and move. Okay. If player is not self current player, yeah, I need to also add self here. Raise value error wrong move order. So now the player is the correct player. So what do we do next? Yeah, we just do self board make move, and self board make move, and we pass the what move as column and player disk. Then okay, if self board winner will be self board check winner, and if I remember correctly, yeah, it's if winner is not none, then what do we do here? Okay, also if not self is ongoing, raise the error, the game has ended. If winner is not none, then we first update self is ongoing, winning disk. If winning disk is not none, false, then if winning disk self player 1 disk, then self winner or self player 1, else self player 2, else actually I don't know what is this boolean that we are trying to return here, like whether the move succeeded or not. We are just raising errors if move has not succeeded. We are not returning anything here. So I can just return, but let's actually return none. And else self if self current player equals self player 1, then else, yep. Or we can maybe simplify this a little bit. Okay, so actually, yeah, self and game of winning disk, and I will do that here. Defs and game self winning disk, it will be disk. Self isn't going false. Okay, so here we have ended the game, and self swap players, f swap players, okay, and here we are returning, oh yeah, we return, we can swap players either way, but I don't think it's really necessary. Let's get the feedback. I still, oh yeah, that's something that I have forgotten. So another note to self, I need to copy things because I'm like too lazy to scroll and check all of these pieces. I probably need to ensure that I have all the logic that I need to implement here. So okay, swap players, if self board is full, self isn't going equals false. So the game has ended, but we don't have a winner. Self swap players, this is as usual. Okay. Yes, move to extensibility. This dep- well, this part depends on how do we want to process this. So if we just want to change it once, we can just change this in the configuration and it would work. If we want to create a different grid configuration for each new board, then we basically need to store it as board variables. And we need to pass it at initialization, and then we just need to change our class instead of pointing to those module level constants to point to variables in this class, and this will work just as fine. Yeah, I did mention this. He mentioned, yeah, game make move would also need to pass the config down. Yeah, yeah. Well, these are all the obvious things. Now imagine we want to make support when AI opponent as player. Currently require a player object to be passed. How do you extend your player class and game loop to support an AI player that automatically computes and submits its move after the human moves? Actually, well, I think what I would do here is just add another state into the player, like whether it's AI or an actual player, but we don't even need to keep track of it too much. We are not using it in any way. It's kind of like external function. So when something makes moves, it's external to the game class. Either it's a person who, like a player, actual player who does this move, or it's an AI that also has visibility into this game. And obviously we can surface some stuff like the game, the board, for everything. Like we didn't mention those methods, but presumably those are like part of the display and we can do that. And then it will be like external thing, external user that makes the moves, and whether it's AI or not, we don't care. Let's see. So I correctly, the core of the question be finding the interface so the game doesn't. Well, it is underdefined. We need to first define how do we instantiate the class of the game, and how do we pass players there. So, well, I mentioned that I won't be using this in game. It's just like to keep track of things. So I disagree. Choose. I'm currently not doing this, right? Like I don't. I always assume there is yet another system like around this game that instantiate this class, instantiates the player, passes those players to the game. We haven't defined this. If we have defined this, it would have been different. Okay, game make move calls check winner, which scans the entire board every time. If we wanted to run a tournament with hundreds of simultaneous games and multiple threads, we're calling make move on different game in the same instance. Oh, okay. Tournament with hundreds of simultaneous games and multiple threads, we're calling make move on different games instances, or even the same instance. Well, it's hard to imagine that several. Okay, we can imagine that several people will try to make moves at the same time on the same board, but probably it should be also like fixed in the UI, on the UI side, that there is a specific player who is making the move, and then it's just impossible for another player to make the move in this time. And then there are always two players per game, so we should never face this. However, if we still want to talk about trade safety here and assume that we don't have any protections on the UI side, external side, and maybe there are also some other issues like the networking or something where we can expect that like two conflicting and concurrent make moves will arrive to our class at the same time. So in Python, we also shouldn't worry because only one of those can possibly be processed because of global interpreter log. But again, let's assume we are not using Python and we are using some other language. The simplest solution would be to just lock the board state, like the game state. So when we are entering make move class, we lock, and then we process the request, and then we unlock it. And it's the most reasonable approach because we don't really like there is we want only one player to be able to do things at a time. So we shouldn't worry about like contention or anything. Yeah, essentially this. Boom, boom, boom. No, I actually mentioned like if we do everything we in make move, we acquire the lock, then we don't need to worry about two things changing and going at the same time because all of the state changes happen inside this make move. Board grid. Yeah, like it's fine if someone is reading the game state while it's being modified and either they get the previous state or the new state, so I wouldn't worry about this too much because if the changes can only move in one direction presumably and everything, yeah, I wouldn't worry about this. Okay, let's see. That actually was great. How challenging it was, just right for me. Okay, overall performance 79% peer average. So entities and extensibility, yeah, I just kind of disagree with what it was providing me as feedback. And implementation is fine, class design is fine. Yeah, well, it's good. thanks everyone. If anyone was watching this, see you other time. Bye.